Hello everyone, this is an Hadoop Introduction Big Data Training class and demo session by kmrdemo Services Private Limited. It is a good innovation solution center for big data, Hadoop and SAP modules and some other technologies. Gives a very well good training and career growth as well. Coming to this big data, this Hadoop Big Data training is given by the Sai Power, and here it starts. Now we are going to see about the introduction on data and problems that facing by the big data and why we are going for and where we for the big data, and we are going for the Hadoop introduction. What is Hadoop and why we are going for the Hadoop and what is the name of the big data. Everything we are going to see in this video session. Coming to the data, what is a data? A data is a collection of information, and as of all we know that data is in some categories like unstructured data, semi-structured data and structured data. As of now this is very well and fine, but apart from this the data can be categorized in some categories. The first thing is, and this categorization of the data can be goes into some problems. We have a problems with the data and some categories of the data, and by to overcome to face these problems in the industry, now we are going to the solution towards a problem that contains towards the data. Now coming to the problems, here I would like to calculate the data in terms of ranges. So the ranges will be started from bytes, kilobytes, megabytes, gigabytes, gigabytes, terabytes, petabytes, yottabytes, etc. Okay, as is seen here in this point, bytes, KB, MB, GB, TB, ZB, PB, YB, etc. So I can name this data category in terms of like volume. This is fine. This is first category I would like to mention, and the second category, as you saw in the previous slide, you will get unstructured data, semi-structured data and structured data. What is a structured data? Structured data is a data which contains a schema. The best example that we can see in our daily lives is any database if we take, or any RDBMS structure we take. It contains a rows and columns and some structure. If a column contains a date as a variable, and we can only fetch we can only store the data of that particular column, it contains only date data. If you go with the numeric, only numeric data can be stored in the numeric columns. So that is because of schema kind of thing. Now coming to unstructured data. This unstructured data is a data where we can see in every file we can see. For example, if you go with the Word document, or if you go with the PowerPoint presentation, if you go with any video format or audio format or any format that belongs to the file, is said to be as a unstructured data. The best example is we are seeing in our daily laptops. And semi-structured data, the combination of unstructured data and structured data is said to be semi-structured data. Here you can see the semi-structured in daily lives, where the question is Facebook, Twitter, LinkedIn or any Google Plus or anything. And this category I can say as variety of the data, right? Okay, next. If you see a file that contains 1 GB of 1 GB of file in your laptop, and you want to copy or transfer or move from one location to another location within the laptop. For example, if we have a C drive and D drive, C drive you have a file and you want to copy to the D drive. Now what you will do, you will just copy. There, when you are copying a huge file, you can see a progress bar. Okay, that progress bar will be that shows some of the data criteria like source, destination, data speed, and progress time remaining, everything. And that is all regarding the data, right? Though that's a can be called as a category, and that category I can say as data transfer, and the category name is velocity. Okay, fine. Now these are the problems, and actually these are the categories in the data belongs to the data. And here the point is, I would like to mention there will be a problem in each category. Coming to volume, coming to variety, and coming to velocity, there are some problems in each category, at least a problem in each category. Coming to the volume, in real time, if we want to store the data or if we want to process the data, we can store up to gigabytes only or maximum extent of terabytes. You may get the question, some of may get the question like, sir, we have a terabyte. Teradata is a database which can store the terabytes of the data. Of course it is there, but it is a commercial. There is no free space, and license cost of things are able to do here. So suppose if I want to store the data and process data, that can be only up to gigabytes only. If the data increases here, the persistence and the consistency of the existing systems performance will goes down. Whatever all the data increases, the performance should be stable or should be increased, where data should increase. That needs to the present situation. Okay, and this is one of the problem facing here. In variety of the data, we are facing the data like, for example, if we take from 0% to 100% of the data to be calculated of the variety category, 0 to 100%, 80% of the data be the unstructured data and 20% of the data will be the structured data, right? And this structured data we can see only in the RDBMS, and this RDBMS we are using in application where business transactions existence in banking sector. Then the question is, the 80% of the data where we can store and where we can process for the real-time analysis, either be transaction or either be analytics. That's a problem where the data is facing severely, because if you see, in the moment you will let you know why this unstructured data is be 80%. Why? Either be unstructured data or semi-structured data. Why it be a 80%? I will let you know. Okay. Then coming to data transfer, what is the problem with the velocity? The best example is, let's consider a laptop which contains 1 TB of a data, and you would like to transfer this 1 TB of data which contains in your laptop to external hard disk. So how much time it will take approximately? Just think for a 2 minutes or a minute. Maybe some of may got the doubt like, it depends upon the RAM, it depends upon the system configuration, it depends upon the hardware configuration, and it maybe depends upon the USB port. Of course. Okay, let's assume 3 GB RAM, Core T2 processor or i3 processor, and USB port is 2.0. And this is the practical thing which I done practically, and you believe or not, it will take minimum a day, less than a day, like 12 hours, minimum at 12 hours. Because why? Because there the data is transferring sequentially one by one. The file is transferring one by one sequentially from one location to the external hard disk, right? But see, the 1 GB 1 terabytes taking one day, is it preferable to allow this kind of in the real time? For example, I want to store a data uh, which contains 10 terabytes in 10 minutes. Is it possible to do? It's not possible with the existing system with this velocity of the data and transfer rate. And you observe the transfer speed will be the consistent, like you can observe in the progress bar 30 MB per second or 35 MB per second or maximum extent of 40 MB per second. That will be the constant. If we increase hardware and hard disk will get crash. That's the one problem, that hardware specifications and it cannot be increased. That is one of the problem. Okay. And in 2006, the point now we are going to see, in 2006 the digital universe, which like a files or data whatever it contains, a digital universe, it contains 0.18 zettabytes in 2006. Now it is 2016, almost we are end of the 2016. For example, it's a September month or October month or November month, whatever it doesn't matter. We are in the 2016, and you can imagine how much the data can be increased in 10 times of the 10 years, right? And an interesting point is, do you know how much data does Facebook's getting from the users? For example, now you are going to see this point. Facebook hosts approximately 10 billion photos, taking up 1 petabyte of storage, right? So if you compare to the previous point, the size of the digital universe, you can imagine how much data will be generating a day. Per day 10 billion photos means 1 petabyte of data is going to the Facebook storage servers. That is only for the Facebook. Then what about WhatsApp? The people have cell phones and iPhones and smartphones, okay? And everyone are using smartphones. More than the Facebook, the people are using WhatsApp. Then you can imagine how much the data is going to WhatsApp, like photos, videos, video sharing, photo sharing, or any data sharing, charts, everything, messages, everything. You can imagine. In such kind, this problems is true or not. I cannot store the data which is more than gigabytes, like terabytes, and I can't store the data and can't process the data which is in the form of unstructured data and semi-structured data, and the velocity I cannot go with the data transfer more efficiently. And to overcome all these problems, we are going with the big data. Big data came into the picture to solve all these three problems. And according to Wikipedia, we got a definition. The definition is whatever the data which is have the large volume or large content or complex data that can be dealt by using big data, which cannot be done by the existing systems. That is the definition given by the Wikipedia. Okay. See here, in information technology, big data is a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools. This is the definition which I said previously in my own point. It be the same. And in big data, we have so many categories like Hadoop, machine learning, data science, and IoT. Okay, and here Hadoop solves all the problems. How? Whatever the data, it doesn't matter. In a moment I will show you. In a moment I will show you the simple architecture of Hadoop, and Hadoop solve all the problems. How? Hadoop contains a cluster. What is a cluster? Cluster means a group of machines to be as a unit is said to be a cluster. It contains a cluster concept, and Hadoop, whatever data is to be stored and processed in the Hadoop, it will be in the form of file. Whatever, it doesn't matter, it will be in the form of file, either structured data, unstructured data, or a semi-structured data. It will be in the form of a file. Okay, so if you go for the previous slide, variety of the problem gets solved. And since I said here we have a cluster concept, the cluster will be a single node cluster or multi-node cluster. Cluster means a group of machines will be there to be as a unit is said to be the cluster or a multi-cluster. Since we have many machines, the volume of the data also will goes, the problem also will get solved. And data transfer, since that's as a multi-cluster, and we have some example, I'm going to be make a question, and from the question the answer will goes to be a solution with this data transfer velocity category. Okay. Now before going to the in deep, just I would like to go with the where this Hadoop came into the picture. Actually, Google, for its internal storage purpose, it's implemented its own file system said to be called as Google File System, and it released it as a white paper. Considering this white paper, this Apache Foundation is an open source foundation. It will works on only weekends, and the people are from the different organizations. They made as a group, and they came here as an organization, and they formed as an Apache. Some of the members from the Apache, they took this white paper given by the Google paper. Actually, Google internally implemented Google file system and released it as a white paper, and this Apache Foundation Hadoop distributed file system they implemented in this name, and this became a top level project in 2008. This is for the storing of the data. Now for the processing of the data, Google for internally it's implemented a MapReduce, a concept and a technology internally, and they released it as a white paper as a MapReduce. This is, you can see here, it simplified data processing on large clusters. And in 2004, and considering this as a white paper, they implemented their own technology. It's said to be as a MapReduce for processing of the data. It became a 2008. It became a top level project. And for database, apart from RDBMS, Google its own implementation of a database called Bigtable. It's a distributed storage system for structured data, and it is implemented in 2006 and released as a white paper in 2006. And HBase is a database which is different from RDBMS category, and this HBase is said to be a database in Hadoop system, and it became a 2010, it became a top level project. Cassandra is also one of the database, and these databases are not apart from the RDBMS structure, and this belongs to be NoSQL data structure. You may heard, some of the people may heard, this is NoSQL, and NoSQL has some categories. In those categories, these two databases belongs to columnar databases, where data will be stored in a column oriented. Now there are some other like Google Graph database and some Dremel interactive analysis. Here Apache Drill and Spanner in the still process. Okay, this is some brief history regarding how we got the Hadoop. And Now I said HDFS architecture. Uh, Here we are going the storage purpose, that is said to be HDFS. If you see in the previous slide, this is for the storing of the data. Now I'm going to give a brief introduction which makes a sense of the problems we figure out, like volume, variety and velocity, that will get overcome by you seeing in the next slide HDFS architecture. Now I have a client. The client may be a system, a laptop or a desktop or any local file system. Okay. Now the client contains a file. And now going to the Hadoop architecture. In Hadoop architecture, we have some services internally, that is said to be name node and data nodes. And this entire thing is said to be called as a cluster, which contains 4 missions. Now I said previously in previous point, a cluster is said to be a group of missions. To be as a unit is said to be a cluster. Now here I am getting a 4 missions. In the 4 missions, one mission will be the master and all the rest of the missions will be the slaves. And in this cluster contains master slave architecture, where master is a main thing and slaves act according to the instructions given by the master. The best example in the software field is we have a team lead and the juniors. Juniors will act according to the instructions given by the team lead or a project manager. The same thing that happens. And whatever the work that doing by the team lead given to the team members, the metadata will contains there. Okay. Now here the point is I have a file. The file name is f1.txt. I would like to store this file which is in the client. Okay, which is in the client. Now the client wants a file to be stored into this Hadoop architecture, which is said to be as HDFS, Hadoop distributed file system. What the first client will interact to the name node. Name node will interact to the data node, whether any space available, all the data nodes, whether any spaces are there or not. And name node will come when interact to the data nodes. Data nodes will give its reply. Each data node will give its reply to the name nodes, like data node 1, data node 2 and data node 3. Whether any availability space are there, whether any mission is proper or not, everything will be, information will go to the name node. The same information name node will pass to the client of the data nodes, and it will give some privileges and permissions in order to keep this file into this HDFS or Hadoop system. And what client will do? Client will push the data into this data nodes. Okay. And now see here, the data will be dividing into the blocks B1, B2, B3 blocks. You may get the doubt, what is this blocks and what is happening? Before going in deep in this technicality, here I would like to quote a question, like suppose I am a librarian and you are the people, one of the people, you are assistant in my library. Okay, I have a 10 racks. Each rack consists 10,000 books. Time to time the books may vary. In each rack books count may vary, like a rack contains right moment 10,000 or 1,000 or 5,000 or 1. It depends upon, because users or people used to come to the library, they used to read. Okay, like that each rack will vary and each books will be vary to each rack and each of all 10 racks. Listen carefully. Now the time came, you are the assistant in my library. There is no records, nothing, everything. Manually I given a work to you. in 1 hour I need the total books count of all 10 racks. In 1 hour I need a total count. There is no system, there is nothing. Manually you need to count. Whatever you do, it doesn't matter for me. Whatever I repeat, whatever you do, it doesn't matter for me. I need a total count of books of all 10 racks in 1 hour. Let's think about that, what you will do. Any answers? Here the answer is, for example, if you are the person, you can't count a 10,000 books in one 10,000 books in one for a one rack in 1 hour. It's highly impossible. For example, for your for your luck or unluck, it doesn't matter. All 10 racks contain 10,000 books or 9,000 books in one rack or 8,000 books in one rack. You need to count manually. In 1 hour, it contains for one rack will be sufficient for you. Then you can't count 9 racks. What you will do? You will bring 9 people and you will distribute each rack to each person. You will keep one rack with you and you will distribute each rack to each person for the 9 people. And when the time gets started, each person will count his own rack and they will give their own count, and summation of all the rows of the racks, you will get the total 10 racks count. There what happening, first you are distributing the work, okay, and in 1 hour the work is doing the parallel distribution concept. Parallelly work is happening and the work is distributing equally to all the people. The same concept we are going to be applied here. When the file want to store into the Hadoop architecture or Hadoop system, file will be divided into the blocks B1, B2, B3 blocks. It will make into the parts. The parts is said to be as a blocks. The block is B1, B2, B3. When the client got the privileges to store the file in this data nodes, where name node is a master, name node doesn't store any data, where data nodes will store all the data. Now the moment has came, this file will be divided into blocks and each block will divide into each machine, okay, and wherever this block is stored of that particular machine, those information will be passed to the name node. So name node contains only the metadata. Since it is a master, it should contains only the metadata. The best example is, if a team lead give a work to the team members, whatever the work and the process and progress of the work, it will be with the team lead, okay, and the work will happens with the team members. The same criteria or scenario happens here, and that's fine. So I stored the data, I copied the data or moved the data here. That very well, fine. Now I would like to get the data from the Hadoop system. Okay, how can I get? When the client will interact to the name node, and it will ask, hey name node, I store the file f1.txt in your system, in your Hadoop system. Please retrieve back. I need some purpose. I want to process. I want to do something with respect to that file. Please show me the file. What client will do? What name node will do? Name node will go to data node 1, data node 2, data node 3. It will ask whether any of blocks are there or not, and it will get those data from the name node and it will show to the client. Okay, that's fine. Now what will happen? Actually, all these missions should be in the time synchronization. Okay, for example, when I'm retrieving the data or before going to retrieve a file f1.txt, from this Hadoop system, data node 1 get failed. Okay, in this scenario, can I get a file? No, because f1.txt equal to b1 plus b2 plus b3. Since data node 1 get failed, which contains b1, I cannot get this file. So what to do? In order to overcome this problem, while file is transferring or storing from client location to Hadoop system, the file is dividing into blocks. Okay, at the same time I'm dividing into blocks. At the same time, it is storing into each block is storing into each data node. The same moment another operation also going to be happen, that is duplicate replication factor. Means the default replication factor is 3 in Hadoop system, means one original copy will be available, and apart from that 2 duplicates will be automatically created and automatically distributed to all the systems among all the machines. Like B2, here if you see here, for this data node 1 B1 is a original, but I need B2 and B3, B2 B3, and for data node B2 is original, so 2 more duplicates are need to be keep in the machine, B1 and B3. In data node 3, B1 and B2. Okay, fine, that is very well and fine and cool and good. Now since the data node 1 get failed, although data node any of the mission get failed, I will get the data. How? I will get the blocks from B2, B3 from data node 2 and data node 3, and either of the depends upon the mission availability. I will get the B1 block. So if one mission fails, there is no loss of data, right? There is no loss of data. Surely, damn sure, there is no loss of data. Okay, that's fine. This is a sample HDFS architecture. From this scenario, I would like to quote, we are overcoming all the problems. The best example is the parallel distribution is happening here. Okay, the data is dividing into the blocks, and each block can be stored. Each node, if even one node is failed, we will get the data. There is no data loss. We will get the data from all other nodes. So the concept of parallel distribution, velocity of the problem is overcoming or not. In this scenario, I can store or I can process the data of 10 terabytes in 10 minutes by using this architecture. So velocity problem got solved. Okay. Now variety of the problem. Coming to variety of the problem, whatever the data, it doesn't matter. It will be stored in the form of file. So variety problem got solved. Volume. Since we have the many missions, right? We have many missions and many storage capacities in real time. Volume of the data also got solved. So I said as 10 TB in 10 minutes, that can become true. Okay. Now in Hadoop we have HDFS. I am showing the list of all the services are going to be covered in the course content. That is HDFS for the storage purpose, MapReduce. Actually MapReduce for the processing of the data, and this is said to be as a 1.x. Yarn is also belongs to be a processing of the data, and Yarn is architecture that existing as a stable version, and that belongs to 2.x architecture. The advanced for the MapReduce. For HDFS, we need for the storage of the data. For processing of the data, we need either any Java or Python, any language need to be known. Okay. Sir, I don't know Java. I am not aware of coding, but I want to work with Hadoop, as Hadoop is a good market as it presents. What we will do? Okay, fine. You can also work with Hadoop, although you are not aware of Java or any other language, it doesn't matter. And you know query language. If you know query language, that will be very fine. Mainframes or testing, whatever the background, it doesn't matter. You can come here. If you know query language very well, you can work. How, sir? How can you work? You are saying you can work. How? The thing is Hive. Hive is a warehouse directory where you can create the tables, you can store the data, structured data or semi-structured data or unstructured data as in the form of schema, as we similar kind with respect to RDBMS. That is not a database. Okay, that's fine. Okay, sir, fine, very well. But see, I don't want to store the data. I want to store that in form of schema. Then I can go with, there is another service or another system is there, that is said to be pig. The pig is said to be called unstructured. We can store the data. There is no schema here. Where Hive contains a schema structure kind of thing, a table kind of thing, or a database kind of thing. But where pig doesn't matter. Whatever data, unstructured data, semi-structured data, we can store, we can process the data. And Hive and pig will use for processing of the data. Okay, now scoop. Suppose you have a data in RDBMS, you want to store or you want to push the data or you want import the data from Scoop to Hadoop systems. Scoop is a connector. Zookeeper. You know what is the role of security guard and watchman? Security guard or watchman, first of all, the first point is they will monitor. They are the responsible persons for the people allowing or and existing of the any persons. Okay, monitoring, information, naming, logging, everything they used to do. The responsibilities what I said now, zookeeper will perform. Zookeeper acts as a watchman. Okay, it will act as a watchman. It will monitor entire cluster and it will show us if any error goes on or any health status. And even zookeeper will handle some of the services. By using zookeeper we can handle. Okay, and Flume Kafka. What is a Flume and what is a Kafka? Flume is a thing like, suppose if we have an application, if application generating a logs continuously, those continuous logs I want to store into Hadoop. That can be achieved by using Flume, and the advanced topic is Kafka. Where Flume is a single instance, where Kafka is a distribution. It will distribute the data over its missions, where has a fast performance. And HBase is a database which will be a columnar oriented database, part of NoSQL family, and that will be used in Hadoop system. And Spark. The Spark is now is a hot cake and very well good advanced performance tool for processing of the data. Where if you see MapReduce and Yarn, it will performance that can be done by using, that depends on the hard disk. This MapReduce and Yarn process will be done on hard disk as a backend internally, where Spark will in memory process. Means when we work with a Spark will directly go with RAM and the performance very abruptly very high. For example, in my experience, I have a 1 lakh record of a table, and when I go with a select query, some of the query, for MapReduce for the first time it took 5 minutes. For Yarn it took 2 to 3 minutes, and for Spark it took less than 30 seconds, 30 to 40 or 50 seconds. In real time the people require the faster performance. If you go with a Oracle database, if you give a query, within a no time you will get the query response. The same response we need, the client will or a user or a customer will go with this Hadoop architecture. Okay, with respect to Spark. And What Google will do? Google will give the search engine. In Hadoop also we have a search engine that is said to be a Solr. Okay, fine. And apart from this, if you need any some customized ecosystems, I am ready to make contribute to you. And if you go with a MapReduce, a cluster can be built by using MapReduce architecture up to 4,000 machines in a single cluster as a cluster. If you go with the yarn, you know or you believe or not, just guess how many machines can be configured as a cluster. By using MapReduce, it will be a 4,000. By using yarn, it is like 30,000 machines. Okay, by using that's why now industry is using 2.x architecture, which is nothing but yarn. Yarn is yet another resource negotiator. And see, when I used to go for the learning at initial stages, I came to, by using all these topics, I came to, oh, Hadoop, this is we need to work on this or everything. No, but actually at the end of my course learning on my own R&D, I came to know that Hadoop is only this HDFS, MapReduce or yarn. This for storage and this for the process. To overcome the burden of all the things from Hive to Solar, this all said to be ecosystems, which makes very easy to process of the data. HDFS is the storage of the data, that is fine, but to process of the data, these all are the tools which we are going to very easy, which makes very friendly, easy to work, to process or to store the data, whatever, it doesn't matter. It may be a performance factor also. And here I said scoop, import from RDBMS to any Hadoop system. The same thing that I have a tables, I have a database in Hadoop system, I want to import to the RDBMS. I can do the same thing by using scoop. Okay, fine. Now going to the next slide. We have some distributions. Since this Hadoop is everything is a framework. Okay, if you come here, Hadoop is everything is a framework, and it's an open source. The contribution is given by the Apache. Apart from Apache, if you see here, Cloudera, Hortonworks, Microsoft, DataStack, Mapper, and DataMill. These are the distributors. Okay. This Cloudera or Hortonworks, all these companies, what they are doing, they are taking the open source code, they are making their own GUI, use graphical user interface, where the business logic or execution logic is the same. They are giving their own distributions, and apart from that, they are giving the enterprise versions also on this data. And these are all be very easy to work with. Where coming to Apache, the same source code is the same, but it makes very some comfortable work when giving by the Cloudera and Hortonworks. And you know, in the market is leading with the Cloudera and Hortonworks, and both are competitors with each other. And you go with foreign, you will have Mapper. In US, Mapper is very crucial, very important. If you see down here, all these are Apache, Hama project, Flume. I said Flume. R is an analytic tool. This will be used in data science. NHBase is a database. This is a pig. This is Ambari. It's a monitoring tool. This is a Hive. And Mahot is a machine learning. Scoop, I said. Okay. And what are the fortunate companies they are using Hadoop? LinkedIn, Facebook, Yahoo, eBay. You know or not, Hive came from the Facebook. Piggies came from the Yahoo. They implemented internally its phone, and they contributed they made it as an open source. Now where Hadoop? Okay. And coming to the use cases, timeline. What are the timeline? Coming to Hadoop development, my course structure is 30 to 45 days duration. either weekdays or weekends. Weekends it took 4 to 5 weeks, and it will be the duration either be online, offline, or self-paced learning. Okay, or and for this course structure we need Java as an optional. Okay, it doesn't matter, but the thing is, in my course everything, if you go to any other, I don't know, in my course apart from everyone, any other tutor, I think, as of my knowledge, my experience, everyone will go with HDFS command line or terminal, Hive command line or terminal, Pig command line or terminal, Scoop command line or terminal, Zookeeper command line or terminal, Flume command line or terminal, or HBase command line or terminal, Spark command line or terminal, Solar command line or terminal. Maybe Solar, I think there is no course, maybe Solar in other thing, but my course will be like everything will be the practical oriented, and I used to monitor whether you done the practical or not. If you not done practical, I won't go to the other topic. The perfection will be there. Apart from all these terminals, and each topic I will cover with respect to programming also, because in real time, for the training purpose, Java is optional. But if you want to sustain in Hadoop as a career, a minimum level of core Java is very important. For that core Java, there will be some APIs, and each API, this is the point which I am telling from my experience. uh, I used to make, for example, I will let you know the how data will be stored by using terminal or command line. After that, I will show you a program, and I will make you to practice on that program how to store the data from one location to another location, how to store the files, how to copy the files, similar to how to create the tables, how to manipulate, how to do the process using pig, using some program. This is very important to survive, sustain in the, to make Hadoop as a career. Okay, and this is very crucial. Of course, Hadoop is very important, and apart from that Hadoop development, I will give assurance, like, the market is very good. If you make a good experience, I will show you a good project POC. If you make a career, I will show you a mock interview kind of thing. I will assist you in the mock interviews, and everything perfect. I will make you as a perfect, because, and myself is a Saipon, as I said in the initially. I have a 3 years of experience. I started my career as a Hadoop developer, and I know Hadoop administration. I'm very well trained in Hadoop admin also. This 3 years experience, I used to be an interview panel member, so I came to know how people are getting the gap as either be a gap as experience or genuine experience. But I know how industry is looking the genuine quality people. They need only the quality people. Even the people, so many people are there, the market is not like, so many people are there, but the quality or the resume building or the project they want to keep, and the quality purpose is lacking. That issue, the assurance I will give, I will cover that quality. Okay, and every scenario I will make some Java program. I will show you Java program and make you practice. If one concept is clear, is completed from my side, it means the practicals also you done from your side, then only the concept is completed from my side. And Java is optional, but I recommend, if you learn Java, it will be helpful for your career growth. Of course, if you go to the some MNCs, no need of work with Java. just a Hadoop training knowledge is enough. The best example is, if you go to the MNC, they won't give the Hadoop all the structures like Hive, Big Scoop, MapReduce, HDFS, everything they won't give. Recently, I got some profile from MNC. Like the description is like this: Scoop. They used to work only the Scoop. The package is 6 lakhs. It doesn't matter. They don't need even Java coding. Everything doesn't matter. Only they have the knowledge on Scoop, HDFS, MapReduce. Does it? Does it? Some Hive. They said that no need of Java knowledge anything. No. Okay. In such cases, Hadoop is very well fitted in my MNCs. If you want to go with a mid level like level 3 or level 1 or product based, sometimes you need the Java because everything is developed on the Java. The product is developing on Java or Python. Coming to Hadoop admin, I am also very well good at Hadoop admin. What I will do is, in Hadoop admin, I will make you the first basic Linux commands, either be Hadoop admin or Hadoop development, it doesn't matter. First of all, I will make practice of basic Linux commands, since this entire Hadoop is works on Linux systems. And I will go to each and every topic continuously. Coming to Hadoop admin part, I will go with the Hadoop distribution, Apache distribution, how we can configure single node cluster and multi-node cluster from the Apache distribution, each and every phase. This is very important because next step is Cloudera distribution and Hortonworks distribution. I will show you single node and multi-node cluster. I am assured I will give of 4 to 5 node cluster. And people may ask, I want to practice on 10 node cluster or 20 node cluster. The number of the node cluster, it doesn't matter. The same thing that will happen, and if the time permits, I will let you know in future surely to work with a 10 node cluster minimum. But there the performance, bandwidth, everything, it matters. Whatever I shown in the Hadoop slide, every service need to be configured, and the Hadoop admin people need to know which file, which module, and which way to configure, how to configure. And Hadoop admin is to build the cluster, to troubleshoot the cluster, and to maintain the cluster, and to add the service. If new ecosystem came into the picture, if the client or user or customer or a management asked, please work on this, or please add this ecosystem to the Hadoop system, so Hadoop admin needs to add it, and they used to submit the team. Say in this Hadoop admin practice, 60 to 80% of the practice should be done by the student itself. Then only I will be satisfied and student will be satisfied, because Hadoop admin not contains any theory. It contains 60 to 80% of practicals that student need to be do. And I will there in each every time. I will be there, and I will assist you every time. And Hadoop admin, there is some security concepts are there, very advanced concepts. The people who want to keep like a 2 to 3 years gap as experience or something, the people like mid level or high level, they want to shift to the Hadoop admin. Okay, obviously they used to keep 1 year or 2 years of experience. They can keep, not a problem. Even Hadoop developer also can keep, it's not a problem. And they can Hadoop developer, I will take care of everything, each and everything. And for Hadoop admin also, I will take care of everything, each and everything. But the people who are going with the Hadoop admin, I can assure, please make of practice. Then only you will get more practice, more knowledge, and more you can go with the more perfect with the interviews. Even Hadoop also the same thing that reflects. And this is of the my demo, and thank you for listening all entire demo. And thanks to Kmrdemo for giving this opportunity to contribute my demo through this demo session. And guys, If you have any queries, please email to info@kmrsoft.com or kmrss.sap@gmail.com, or you can contact to 703259838. And I'm the trainer. I have a big data blog which has a very good stuff for the big data learners, beginners, or advanced learners. If you have any doubts or any clarifications, please feel to contact at any time, any moment, and our institute people will make a conference call if you have any further questions or queries, anything. Hope this session make you feel satisfied. Thank you very much.